Hello peers, today we'll be going over a starter lesson on the concept of food webs. The overall aim for this lesson is for students to gain an understanding of what a food web is and how the factors within the environment connect and function together. The students' learning intention is to understand that living things have needs and how living things are connected. The students' success criteria is or can be from the following. I can make a food web using the items provided. I can explain what the arrows mean within a food web. I can collect my own data. I can use my data and represent it in the form of a food web. And I understand what happens if there's something missing in the food web. This success criteria can be changed and adapted to suit the needs of your students and to gain the best out of the lesson. What's involved within the activity? Students will participate in the process of individual data collection and observe foods and decide whether they would eat the items that have been laid out on their tables. Students will then observe the items on their tables once again and create connections between the items in the form of which item they think will eat each other in the natural environment. After their data collection process, they will then collaborate their data with the other students and create a physical food web using the items on their table. I will now represent an example of the activity in which my younger brother completed. My brother, who you will see in the photos, had very basic knowledge of what a food web was, but he was able to complete the activity without any adaptations being made. The images you are seeing on your screen now are the 5 items that I decided to use within this activity. These items were a carrot, soil, grass, worms, and chicken. These items are just examples of what can be used within the activity, as there are a number of different items you can add or change into this activity, but this leads to the creation of a different food web. I made sure that the items were clearly labeled to ensure the students know what each item is, and to know exactly what to look at when they're filling out their data. Students will be given a data collection sheet before they start their activity, and as a teacher, ensure to explain to the students how to collect the data using the sheet. The students are required to collect 2 sets of individual data, with one being what they would be willing to eat from what they see in front of them, with the food items that have been laid out on the table, and the other set is to investigate the connections between each food item and record what item would eat each other. It is important that students look after the data sheets, as they will be collected by you, the teacher, at the end of the lesson. This data can be useful in planning future lessons and gives you an idea on what the students need to work on. Within this image, my brother is at the beginning of the activity, in which he is observing the items I've laid out for him on the table. It is important that students have a chance to observe each item and allow them to ask questions about the items. For example, when observing the items, my brother asked if the chicken he would eat will be cooked, which I answered yes, which changed his collection of the data. He then moves to collecting the data for the rest of the items and decides what items he would eat. His results are shown on the next slide. As you can see, my brother has collected his data, and from his data collection, we can see that the only item he would eat was the chicken, and explained to me he avoided the carrots as he didn't like them. This shows a clear example of a fair test within this activity, as each student will have different preferences to what they would eat, leading to a variety of data being collected. This section of data collection is important as it allows students to gain an understanding of where them as a human may fit into this food web. Humans within the food web is a concept that can be later explored once students have gained an understanding of how and what a food web is. So when we come to the floor and discuss our findings, we can ask the students, how may we fit into the food web that we've created, and what happens if we're not in the food web. My brother then moved on to collecting his second set of data. He found some answers confusing as he didn't know if certain items connected with each other, but I advised him, as you should advise your students, to put what they think connects with each other as it is their own data, and again ensuring that a fair test is being created. When students return for a discussion later in the lesson, it is important that you use their data to explain the concept of consumers again, and they show them that an item like grass can consume nutrients from the soil, meaning they have a connection within the food web. Having this understanding allows them to create a correct food web using the items on their table. After students have collected their data, it is time for them to collaborate with other students within their class. Encourage students to compare their data with each other and allow them to discuss their reasoning behind their data collection. Encourage students to identify differences within their data compared to other students and explain why this may have happened. Students will gain knowledge from each other and eventually come up with a conclusive result complying everyone's data together. This photo you see on your screen was taken after my brother and I had a discussion about his data collection. We discussed each item and their connections and come up with a conclusive result. He then used the arrows on the table to create a physical food web using the data to assist him on what connects with each other. It is important that students are aware that within a food web, an item can have more than one arrow on them, as the item may be eaten or eat more than one item on the food web. Allow the students to use their data and the ideas they came up with during the discussion to create their own food web using the items on their table and the arrows to connect them. Provide students with 6 arrows, which is the correct amount of connections within this food web. As the teacher, it is important to move around to each group and observe the conversations being had between students and look at the food web they are creating. It is important to note down which connections they have made successfully. The image shown is what the teacher should aim for the students to create, but this is not the end game result of the activity. The aim of the activity is for students to gain an understanding of food webs and what they contain. After the completion of the activity, students will return to the floor where they will participate in a teacher-led discussion about humans' inclusions within the food web and how we affect them.
So for findings, in the part 1 of the activity, students will gather the 5 food items. So you can try this at home. You'll need carrots, soil, grass, cooked chicken and worms. So make a table and record results of what you would eat. Tick or cross yes or no. So there's just a picture there of my one. And this helps students to understand where they fit in the food chain and to understand concepts of food chains, which is a component of food webs. For activity part 2, students make a table of what eats what, which you can see here. So make a table like the following and tick or cross the box yes or no if that food eats the corresponding food. Hope that's not too confusing. You can see it in table 2. So on the left you've got what is eating, what's on the right, which is being eaten. This starts students thinking and reasoning to scaffold their construction of the next task, which is making the food web. So for activity part 3, students use arrows and arrange plates to construct the food web using the table in part 2. So if you want to cut out 7 arrows and arrange the plates to construct the food web using your part 2 table. So here, I think I've got some different results to the other people in my group, but yeah, it's kind of confusing. But you can see, for example, soil is being used up to grow the carrots in this picture. So findings will be presented in a table and foods classified as either would or would not eat. The variable of food types is controlled by being the same for the whole class, so we're all using the same 5 foods to make the food web. and data will be interpreted by students drawing on own and peers' prior knowledge to construct a model of the food web. So that's using science principles. And these two focus questions, did you think about what soil eats? So in my food web, there were no arrows going to the soil. So we'll have a discussion with students about the role of decomposers that feed on dead organisms to feed the soil. Second focus question would be, where would you put humans in this food web? Thinking, are we predators or prey? That's about it.
For the activity, I had my brother complete it, and at first, he showed a good understanding of what he would and wouldn't eat, and filled out the table accordingly. As you can see, he filled out the table saying he would only eat the chicken and the carrot, and nothing else. However, when it came to matching producers and consumers, he struggled a bit, and it took him a little while to do it, as he was unsure what ate what. But in the end, he filled out the table well, and then created a corresponding food web with some arrows, and had the right idea in the beginning. However, he made a very common mistake, which I will go into later. But he put the arrows in the wrong way. I did, however, correct him, and he reversed it, and he now understands the concept pretty well.
The safety considerations for our activity include like dietary requirements, because the students will be eating food, so that might be like religious or allergies. Hygiene, so prepare the food in a health approved kitchen, and students are to wash their hands before the activity, and each student has their own plate to minimize spread of germs. Also using plastic plates because they're grade 1, so we don't want anything to smash. And as well, ethics, so sending like parental consent and dietary forms, and have them returned before the lesson starts. Background information on the science concept of food webs and food chains. So the food webs represent energy moving through the ecosystems. Arrows indicate direction of energy travel between organisms. For example, grass is eaten by mice, shown in this diagram here. Food webs are unique to the habitat and are made up of multiple food chains. So food chains are a hierarchy of what eats what in the animal kingdom and with plants as well. Food webs connect food chains of different organisms. So for this activity, have a think about, these are 2 food chains, and have a think about what organisms on the left would eat some of those organisms on the right. Using 2 arrows, what are some places you could draw the arrows to connect the food chains and make a food web? So just as an example, the seal eats one of the larger fish and also eats krill. So that's an example of a food web connecting 2 food chains. So food webs are basically an order of trophic levels. So the first trophic level is producers. So in this picture, that's grass, and they make their own food. So for example, grass here makes their food by photosynthesis, which is a process of turning light energy, which you can see in the diagram, using carbon dioxide and water to make glucose or sugar. The second trophic level is consumers. So starting with primary consumers, which is the mouse in this diagram, which feed on the producer. Then the secondary consumer, which is a snake, feeds on the primary consumer, and the tertiary consumer, which is a kookaburra, feeds on the secondary consumer. Then thirdly, there's decomposers, which feed on nutrients from dead animals or plant organisms. So once the kookaburra or grass dies, the decomposer, which is mushrooms or fungi here use that to provide nutrients back to the producer into the soil. So that's basically the cycle of the food web. So we'll be using principles of constructivism in the lesson. Teachers scaffolding student construction of food webs and responses to teacher-guided questions uses constructivism theory. So there's two theories, being individual constructivism, which is Piaget, and social constructivism, which is Vygotsky. So teachers are the expert that facilitates students moving through the zone of proximal development, according to Vygotsky's theory. And in eating the food and making food webs, students construct their own knowledge, which is individual, and draw on others' knowledge, so social constructivism, to draw conclusions about which order the food web is and where the arrows go. The science skill of analysing and evaluating is achieved by students looking at their own data, comparing with others, drawing conclusions about the food chain hierarchy, and that's also tying into general capabilities of critical and creative thinking, particularly using ideas in own and others' reasoning and sharing points of view, discussing information and ideas used to help reach each point of view. So students have to draw on prior knowledge of wild animals and food sources to reason through making their food chain and bouncing ideas off each other to draw conclusions and solve the food web.
I'll now talk about catering for different types of students. First, we will talk about an enabling prompt. Now, an enabling prompt could be to remove one of the items from the food web to create a food chain, to aid in a better understanding of a simpler concept, or provide students with an already completed food web before they start the activity, to better consolidate their understanding of the concepts. For students who want a challenge, they will have an extending prompt where they can use a table of results to create a corresponding food web and detail why certain items are in certain trophic levels. This is to consolidate their understanding of how a food web works, and they can also add more items and see if they fit within the food web to add more of a challenge. A common misconception in food webs is that the arrow means eats. This was shown by my brother in the earlier results, as he had reversed the arrow by mistake. When children draw a food chain with the arrows reversed, they wrongly indicate that the primary producers are the predators of the primary consumers, even though they will tell you that the reverse is true when prompted. This is called a force arrow, which is drawn away from the subject of the force and towards the object being pushed in physics. Arrows in cartoons show the movement of a character or object from one location to another, but this one represents the transfer of energy through the ecosystem, the energy of the producer or inferior consumer to the superior consumer/predator. This problem can be difficult to solve since it demands rote learning of a rule that contradicts the common understanding of a drawn arrow. However, there is a method to help children understand the way the arrow works. We can use the Pac-Man rule, which refers to the well-known video game character and the direction he eats, not the direction he moves. So whenever a child is confused, they can just imagine Pac-Man eating in a certain direction, not the way he moves. Now, how does this activity support students? Well, this activity demonstrates why it's important for humans to look after the environment, as not only do the animals affect each other, but also humans, as we live off of animals and off the produce that animals may create. Therefore, it is our duty as humans to protect biodiversity as a whole to create a sustainable world and to protect each individual ecosystem. A good example of how important a single species can be is monkeys. What if the monkeys that eat the fruit and plant the seeds that feed thousands of other animals were to suddenly disappear due to natural causes, such as natural disasters, or human interaction, such as hunting and deforestation? How would this affect the ecosystem? How does the destruction of a habitat affect the food web and the animals that are a part of it? This question should allow students to reflect on the importance of even a single species such as the monkey, as this would cause massive harm to the food web, as they don't plant as many fruits and produce for other species to survive on, causing a decline in the ecosystem. And certain animals would die without food produced by the monkeys, and those animals' predators will also struggle to live as their food is also massively declining due to them not being around anymore. This discussion will allow students to see the impact even a single species can have on an ecosystem and food web, including humans. The activity can also lead into a discussion on ways in which students can help protect biodiversity now. Some ways is by changing little things in life, such as less food waste, recycling, picking up litter, and producing less carbon emissions through walking more and driving less. Overall, the activity influences children to think carefully about their place in the world and how it can affect all different types of ecosystems, including their own, and will allow students to raise awareness for environmental issues across the world and learn how to protect biodiversity as a whole. Thank you for watching our presentation, and we hope you enjoyed.